This is the Chapter 2 recap. I don't want you to get so lost in the details that you lose sight of the big picture of what are you doing in calculus. In Chapter 1, we were talking about limits. And the question of what is a limit is if you pick some x value, the limit was the y value that that function was approaching. That was the short answer for what is a limit. It's the y value that the function approaches at some particular x value. The short answer to the question, what is a derivative, is if you pick some x value, the derivative is the slope of that line, is the slope of the function at that x value, right? If you pick a different x value, you've got a different slope. Okay, so the short answer is here, what's a limit? It's the y value the function approaches. What's a derivative? It's the slope of the function at that point. Now we had the limit definition for a derivative, and that's a formality. We'll review it right before the AP test because it exists as sort of a trivia question, but for now just know that all the rules that we have for derivatives come back to that limit definition. So what are those rules? If you have a plain old function, good old polynomial function of some kind, then we know we follow the power rule, and that's you just take your exponent, multiply it by the coefficient out front, and reduce your exponent by 1. And then we had some special cases, right? The derivative of an exponential function is just itself. The derivative of a natural log function we know is 1 over x. And then, of course, we had our trig functions. Y equals sine of x. The derivative of that is cosine. And again, you could prove these with that limit definition, but I think it suffices to memorize these. And then you can memorize the other 4 trig functions. We've seen in the homework that life is faster if you just memorize those. Now some more rules here. If functions are separated by addition and subtraction, it's no big deal. You get to evaluate each piece individually. So like if I had y equals e to the x plus cosine of x minus 4x cubed, because these are separated by addition and subtraction, you get to look at each piece as its own derivative, right? And then that's not too bad. So y prime is just e to the x minus sine of x minus 12x squared. No big deal. If your functions are separated, I can't turn the page, here we go. If your functions are separated by multiplication, you have to follow the product rule. So if you have f of x equals negative 2x natural log of x, if you can, these are the hardest ones to spot, I think, but if you can separate it into 2 functions, a first and a second, that's when you follow the product rule. So the derivative is the first times the derivative of the second plus the second times the derivative of the first. If your functions are separated by division, I think these are the easiest ones to spot. If you're separated by division, that's when you're going to use the quotient rule. This is the one where you're yodeling, right? You've got low d high minus high d low all over low squared. And of course I'm not taking the time right now to clean these up. And then pages are sticking together, please. I'm recording this in the summer. This is how you know it's humid. And then of course we have the graphical representations, and I'm including numerical representations in that of derivatives. So let's say you're given a table, looks like this. You have x and y values, and question says, find the derivative of at x equals 2. And you go, but I don't have a function, I don't have an equation, what am I supposed to do? You have to go back to what's the short answer, what's the big picture, what is a derivative? The derivative is the slope. And when we have a table of x and y values, we know that the slope is just the change in y over change in x, right? Go back to the absolute basics. So if I want the derivative at y equals 2, I'm going to choose the points around it, right? So the change in y over the change in x would give me the derivative at that point, x equals 2. If you have a graph, let's say I have a function that looks like this. Say this is f of x, and I need to find the graph of f prime of x. Again, I just have to think literally in terms of the slope of the line. And so I'm looking for, okay, the slope is almost 0 there, so maybe it's 0 there. And then here the slope is always positive. It's starting out at 0 and getting steeper, so it's positive, so I know I'm above the x-axis. It starts at 0 and gets steeper. Over here, the slope is also positive, so I'm still going to be above the x-axis, right? It's got to approach 0. The slope starts steep but approaches 0. It starts steep but approaches 0. So there's my function. There's my derivative. Right? And it helps if you happen to know what the equation is. This one looked kind of cubic, so it makes sense then that the derivative would be quadratic. So that's the big picture that I want you to keep in mind. The derivative is literally asking for the slope. You can find that by good old rise over run. You can estimate it from a graph, just looking at the slope, see where it's 0, see where it gets steeper or not as steep. And then we have all of our rules for finding the derivative from the equation. So you can use the power rule. If you have two things that are multiplied together, use the product rule. If you have two things that are divided, use the quotient rule.